Good evening and welcome to NASA's Wallops Flight Facility in Wallops Island, Virginia. I'm NASA Public Affairs Officer Trent Parado. We're here to discuss the Orbital Sciences Corporation test launch of its Antares rocket, which lifted off from the Mid-Atlantic Regional Spaceport, Pad A, some 90 minutes ago. We have two speakers joining us today. They'll each give a brief opening statement, and then we'll take questions here in the room and on the phone line. As a reminder, you can find out more information about today's test launch at www.nasa.gov/orbital. You can find all the ways to connect with NASA on social media at www.nasa.gov/connect. Let me briefly introduce our speakers, and then we'll get started. To my left, we have Alan Lindenmoyer, Manager of NASA's Commercial Crew and Cargo Program from NASA's Johnson Space Center in Houston. And we have Frank Culbertson, Executive Vice President and General Manager of Orbital's Advanced Programs Group and a former astronaut. And with that, we'll open with Alan.
Thank you, Trent. Well, it certainly was an amazing achievement for Orbital today, a great day for NASA, and another historic day for commercial spaceflight in America. The flight today was just beautiful, and it looks like the preliminary data says that all the objectives that we established for the flight today were 100% met. All the expectations we had today for today's flight was beautifully met. And that cannot be done without the extraordinary teamwork between government and industry, NASA and Orbital and all our other partners with the FAA and the Mid-Atlantic Spaceport and the Wallops Range and everybody who worked so seamlessly together to make this happen so smoothly today. I want to give a special thanks to my team that's been working with the project since the beginning in 2008 with our partnership with Orbital. Bruce Manners, our project executive, and Kevin Meehan worked very closely with Orbital to help make this happen today, and they really do deserve some special thanks. So congratulations, Frank, to you.
Thanks, Alan.
It was a beautiful flight. Thank you so much for making this happen today, and we're looking forward to the next one, the ISS, the flight to the space station coming up later this summer.
Right.
Congratulations.
Thank you. Thank you very much. My turn?
Yes, sir.
All right. It's great to be here today, especially under these circumstances. On behalf of David Thompson and the entire Orbital team, I want to thank all of you for being here, and particularly to the media, I want to thank you for telling our story, because it is one heck of a story. And as Alan said, it took a lot of people, some great teamwork, and some really tough challenges to get to this point. Today did go extremely smoothly, and it's a real testament to the team that it did. But if you've watched our progress over the last few years, you know that this is not easy, and making it look easy takes a lot of hard work and overcoming a lot of challenges, and a number of people did that. To Alan and his team, Bruce and Kevin, that worked through all of this with us, thank you very much for supporting us through thick and thin and helping keep things going. For today's operation, we had an amazing team that worked well together. We did a lot of rehearsals getting to here. You know, you thought we were just delaying launches, but we really just wanted a few more practice at it. But the Mars team has taken us to the point where we have an amazing pad that will support what we need. We had our liquid oxygen, we had our RP on board, and we had systems that supported our launch processing. And that's extremely important to being able to be successful here. And to Dale Nash and his team, thank you very much. To the Wallops team, led by Bill Robel, Jay Pittman, and the entire team in the Mission Control Center, Range Control Center, and out at the pad, all the safety people who helped us get to here. We also want to thank you for that, because they worked as many long hours as we did, trying to stay with us, keep up with us, and make sure that we really were complying with all the local regulations and helping us get to a successful conclusion. The International Space Station program and the headquarters folks who supervise that, led by Bill Gerstenmaier, have been amazingly supportive. Mike Suffredini and his team, Kathy Leaders, who has gone on to other things, and now Dan Hartman, have been very anxiously awaiting this test flight and the upcoming demonstration so that we can get going with the contract. So they've been helpful also in getting to this point. But I have to tell you, I'm really proud of the Orbital team. The men and women who worked this process and who went through the countdown training, the simulations, the wet dress rehearsal, the practice countdowns to get to today, if you will, just stayed focused, stayed on task, and kept things moving forward in a very professional way. I was very impressed with what I saw in the Mission Control Center. No matter whether it was a minor problem or a major problem, they all pulled together. Led by people like our program manager, Mike Pinkston, the launch director and deputy program manager, Kurt Eberle. They have kept people moving in the right direction and have dealt with a lot of very difficult things. They work for Ron Graby, the Launch Systems Group general manager, who of course has been the overall leader of this effort. And without his leadership, they wouldn't be here today either. But there's one person I really want to single out, and that's Mike Dorsch, the chief engineer, who was not only the chief engineer of the program, but the chief troubleshooter of everything that happened pretty much through the whole program, and especially real time over the last few days. And Mike has exhibited tremendous leadership, great decision-making capability, and in the end, he proved he could be a color narrator, giving us the blow-by-blow on the launch and giving us the details of where we were. And he did a great job with that. And he says that's all he wants to do in the future, I think. No, actually, he just wants to be an engineer, but he stepped right up to the task, and he's really good. There's a couple of other people that I'd like to point out. One is J.R. Thompson, who was our president and chief operating officer until last couple of years, and then he is really focused on this as his major project to get it off the ground and to do the work necessary to do the coordination between NASA, Orbital, Mars, and keep things moving. In addition, we have a couple of prior program managers who've gone on to other things, but who made major contributions in getting us going. And that's Dave Steffi, who's in the room today, and Brent Collins, who I know is following all of this closely, and Brent has retired. Dave's now my chief engineer in the Advanced Programs Group. But these folks helped set the tone, get things moving in the right direction, and helped enable this success today. A couple of other people I'd like to mention are Antonio Elias, who is here, and Bob Richards, who had a major role in helping decide that, yeah, we really are going to build a medium-class rocket, and we're going to launch it out of Wallops. And all of that has come to fruition, and that all happened like 5 or 6 years ago, I think, maybe even longer in terms of envisioning it. But it has come together, and we've proven we can do it, and we're going to do it many times coming up in the future. So my message here today is this is all about people. What we do in space is all about people on Earth. And that's the most important thing that comes out of this. Whether you're doing it for the government or a commercial company or jointly, it's all about the people who make it happen. And it's the expertise that America produces, the educated workforce that we have, the leadership that we exhibit in maintaining a presence in low Earth orbit and beyond. It's all about the people. And so I encourage you to get your kids out there studying math and science and engineering, and talk to your congressmen and congresswomen about the importance of human spaceflight and spaceflight in general, and keep things moving outward. We need to keep moving beyond low Earth orbit, and we're going to help NASA do that by taking over low Earth orbit, providing them with the cargo they need over the next few years, so that NASA can then go on and do the other missions that are important to project humanity beyond the Earth and into the rest of the solar system, so that our kids can actually have that as a part of their future. But back to this event today, the launch went off on the time we had planned. It went very well. The sequence of events went extremely well, and you'll see in the replays the various events that had to happen, such as first of all, getting that first stage all the way to MECO and helping Mike Dorsch get the right time of when it was going to occur. But then separation of the second stage, separation of the fairing, the interstage, and then the payload itself. And all of that demonstrated that when we do this again, we know how to make this happen, and we'll get that payload, Cygnus, into orbit and on its way to the International Space Station so that it can continue its mission and we can provide them the cargo, the experiments, the clothing, the food that they need to sustain and extend their mission, and so that we can keep 6 people up there for an indefinite period of time. And we're really looking forward to being a part of that. So I look forward to your questions. We have a lot of very proud people over on the base and at the Launch Control Center. We're sorry about the fire out there, but that wasn't anticipated, and I think they needed to clear that brush anyway. So it'll all work out in the end. Environmentalism, right? But it's a proud day for Orbital. This is the first of many, many successes to come, and thank you all for being here and help us send the message that we're on our way to low Earth orbit. Thank you.
Thanks very much, Frank. Let's go ahead and take some questions. We'll start here in the room, and let's start here with Stephen Clark. Just get a microphone to you.
Thanks, Trent. A couple of questions. Stephen Clark with Spaceflight Now. First of all, can you go over what orbit you achieved that you have data on? Or was it close to the target? And also, looking ahead toward the space station flight this summer, I know the hardware is coming along nicely, but what about the software and the integration with the space station and some of the big steps coming up in the next 2 months to actually get the go-ahead from NASA to take that flight? Thanks.
Okay. As far as today's flight, we wanted a minimum of 250 kilometers. We're there approximately at 250. We will have to do some additional evaluation to see if we're exactly on target or if we need to make some adjustments. But we think we're very close to that. And the sequence of events, as I said, went pretty much as planned. If we need to make adjustments for future flights, we will do so. But we certainly achieved orbit, and that was the main goal. For Cygnus itself, the Cygnus spacecraft that will fly to the space station this summer has actually been fueled. It's ready to be transferred into the horizontal integration facility, and as soon as that rocket is ready to receive it, we'll integrate the two together, and it'll be ready to roll out to the pad sometime this summer, probably late June or early July. And so we will be on track for delivery, assuming the space station schedule can accommodate us and that we don't run into any unforeseen problems. But as far as Cygnus goes, we've achieved all of our safety approvals. We've been through all the simulations necessary to achieve approval for our software. We continue to look at it and to continue to do simulations, but so far it's gone very well with the NASA participation in our sims. The ops team is ready. We do sims every couple of weeks with the NASA team to make sure we're all on the same page, and we're really anxious to get going with that. So the spacecraft will not be the long pole in getting to the pad. It really will be just evaluating the pad condition to see what we have to do to refurbish it, if anything, and then getting the next core completely assembled with its engines, second stage, and get the fairing in here so we can assemble it and attach the spacecraft to the front end, and then roll it out.
And on the NASA side, there's already been a great deal of joint testing done with the software and the simulating the mission, and that's all gone very well. So what's left is to finish up the verification of the final safety review packages, making sure everything's compliant with the visiting vehicle requirements that we established. Once those verifications are complete, we'll go into a final review of the readiness, flight readiness status, and we should be good to go.
Let's take 2 more here in the room, and then we'll go to the phone line. So 1, 2, and then keep it moving.
G. McCullough, Talking Space. First off, Alan, Frank, congratulations. Has there any information on the status of the CubeSat payload that Antares took up today?
They did deploy, but it'll probably take a couple of orbits before they can achieve contact with them for the ones that are looking for that, because they don't have very many ground stations that monitor what they're doing, but we know that they did get deploy signals.
And just a really brief follow-up there. Did the launch delays actually help the folks in the Mission Control Center sort of iron out the bugs with communication among themselves and so on? Did those delays actually contribute to today's success? Thanks.
I would say that every time you go through an operation like this, it contributes to future success. Whether you get off the pad or not, you're going to go through the same exercises, same communication, same problem solving, which is a big part of it, and get the people on the same page and keep them sharp. So I never see a scrubbed launch attempt as a problem. I see it as an opportunity to get better and better. And I can tell you from shuttle experience, sometimes it takes a lot of attempts to get off the pad, but you get better every time. One of my missions, we said, we finally trained after 2 months of launch failures. So But no, this was good, and every couple of days we were running through it, and the team was really sharp. And the sooner we do the next one, the better.
Let's go to Jeff.
Jeff Faust, Space Review. Quickly, any more details about that brush fire around the pad after the launch? Is there any damage to any of the pad facilities that you know of at this time?
According to the range folks that I talked to, there's really nothing in that area that could be damaged. It's outside the fence, and so it's really just brush burning, and I'm sure they got the firefighters down there pretty quickly to put it out. It doesn't appear that anything around the pad itself was burning, or any hardware or equipment that we would worry about. It was well outside the perimeter of our valuable and Mars's valuable hardware, best we could tell. We'll get more information later.
Okay, let's go to the phone lines, and we'll start with Tarek Malik of space.com. Go ahead, Tarek.
Thank you. I think this question is primarily for Frank, but Alan, if there's a NASA side, please feel free. Frank, I'm wondering what the process is now for the team in terms of just going over the data you got back from the sensors on board the dummy payload, and what the flow is going to be in making sure that everything is set for the summer flight. Thanks.
I couldn't understand that very well, but let me answer what I think I heard. The payload simulator itself, once it's separated from the second stage, we didn't receive any more data from it. We received all the data we're going to get prior to separation, and we will evaluate that as we do a review of the launch data, acoustics, accelerations, vibrations, etc., and that'll give us a good feel for what the launch environments are. We did get very good video from the rocket cam of the fairing separation, the separation of the components, and that's all valuable information to us also. But as far as the payload itself, the payload simulator, we don't have any further data coming from it. So we felt pretty good about what we saw and what we have so far, but that's all we're going to get. Did I miss anything, Tariq?
I was just curious what you saw as like the schedule of analyzing it. I mean, do you think maybe just weeks, or would you want to spend a whole month going over what you did receive? Thanks.
It'll probably just take a few days to get the preliminary data, but we'll continue to analyze it until we launch the next one. You know how this system works.
And I could say, for the purpose of the objectives that we established for the flight, as soon as we saw separation of the payload, that was really the end of the primary mission objectives that we established today. And then to be sure that there was some telemetry and downlinking occurring after the separation, which we had verification of. So I don't think it's going to take very long. It's certainly not going to take days for us to conclude primary objectives.
We had two sets of objectives. One of the Space Act Agreement objectives that Alan talked about, and we, of course, considered those very important. We had to meet those for a variety of reasons, but we also had test objectives that will lead into the success of the next mission, and we always are looking at the data we can achieve that will help us do a better job next time around.
Okay, let's take two more from the phone, and then we'll come back here to the room. Next is James Dean, Florida Today. Go ahead, James.
Thanks very much. Mr. Culbertson, how much tougher is the next mission after getting through this first launch phase? Now you gotta complete an orbital mission with a new spacecraft. How much tougher is that going to be? And also, I wondered if you just might have any early feedback on things like the turnout there, how far away people could see this launch, and sort of reaction from the community up there. Thanks.
Okay, I'm pretty sure I'm not going to hold my breath any less on the next one than I did on this one. Every launch is a challenge, and you want to make sure that it's all done right. So we'll pay as much attention to the next one as we will this one, and we will be at a certain level of nervousness all the way to main engine cutoff and then to orbit insertion. But on that one, of course, we will have the additional challenge of making sure that the Cygnus is actually in orbit and that it deploys its solar arrays, it has its own power, and then it can start its rendezvous maneuvers to get to the station, which will take about 3 to 5 days. So we won't relax for quite a while on that one until we're actually grappled and berthed to the station and the hatch is open. Even then, we'll still want to make sure everything goes right, but that will be a major achievement. So the next one's going to bring its own challenges. And the other question was what?
Just wondered if you had any early reports of things like
the crowds,
turnout
yeah.
or just kind of reaction from people up there to meet this biggest rocket.
Well, in the control center, of course, we couldn't see it live, but we were watching it, and we started feeling the rumble after about 30 seconds or so in the control center. It was rattling the roof. I guess it was the roof. Something was rattling, and we could hear it and feel it in there, which was an amazing experience. But the people who were out at the launch site itself and the viewing site, who came in later and talked to us, and I'm sure there were a few in here that could address that, said they were incredibly close compared to where you are for a shuttle flight, and that it was an amazing experience. And the words that Dave Thompson used were, this was a majestic liftoff and ascent, and I think it was. That's one way of saying it was really slow coming off the pad, and we never thought it would clear the tower. But it is slow accelerating, and majestic is the word I want you to use. But after a while, it was going like a scalded ape. So it was accelerating quickly, and everything was looking great as it climbed into the sky. And it was a beautiful blue sky today.
Okay, one more from the phone line. Let's go to Jason Parr with Wired. Go ahead, Jason.
I was just trying to get a little bit more information about the timing and things during the launch. Did everything progress as predicted? Were there any hiccups at any point between liftoff and shutdown of the second stage?
No, all the events occurred within a second or so of when we expected them. We didn't really see any major anomalies at all, and so we're very happy with the sequence of events and how it all occurred. So we will obviously go in and analyze it much more carefully in the coming days and replay everything to make sure we can get maximum information from the data. But first glance, it all looked really good. And looking at the look on Mike Dorsch's face, it must have been really good.
Okay, back to the room. Let's take a quick poll for questions. Here, left.
Yes, Chris Haber, chrishaber.com. I had a couple things. First, I was hoping you could give a bit of a timeline of your delays beginning in 2011 up to launch today. And a bit on the thought process to not transmit any data after the simulator separation.
Okay, as far as not transmitting data after the simulator separation, that's completely due to the fact there's no battery on board the simulator and no transmitter to send. All the data came through the second stage, which is as it normally is. This was a very simple simulator allowing us to actually demonstrate the capability to get to orbit on a test flight. So the simulator was more of a nice to have. We really wanted to demonstrate the first and second stage and the separation of the fairing and the other components. As far as delays, going back as far as 2011, I really am not prepared to go through all of those. What I want to say is that rockets are hard. Spaceflight is difficult, and getting off the ground is a real challenge for whatever team is trying to do it. And you can see that in almost any organization that's tried to do it. So the way I look at it is we're on a new schedule now, and we're on schedule. We launched today, and the next launch will occur on the schedule that we set starting from today. And we will start delivering cargo this summer, and then we'll set up another schedule that we will operate on in conjunction with NASA for delivering cargo on a fairly regular basis. I think if you look back, the total amount of time it took from the point where we were put on contract for this and the time it took to get to this launch has probably never been achieved before. It's a pretty amazingly short schedule in the bigger scheme of rocket development. And by the time we get to the station, I think that will even be punctuated by that achievement. So the company, in conjunction with NASA Wallops, Mars, our subcontractors, Aerojet, ATK, and others, we've achieved a major accomplishment today in getting this rocket off the pad. And actually, first in getting this pad built and all that went into that in what seemed like forever, but really was a relatively short period of time, supported by NASA, supported by Senator Mikulski and others in Congress, and supported by the state of Virginia. We were able to achieve that. It was a great public-private partnership. And then development of the rocket itself, which was done by Orbital, and the development of the spacecraft that's coming soon, which is done jointly with NASA, has been, even though we set really aggressive goals for ourselves, and when we don't make them, it feels like we're being delayed. When this history is written and you look back, it will be an amazing accomplishment in terms of time and money. And I think that most folks will agree with that. And I've gotten that feedback from a number of people much smarter than me that this is the way it ought to be done. So we're going to keep doing it. We're going to be a great commercial partner for NASA, I believe. And we're looking forward to being an integral part of the International Space Station program and keeping the cargo coming and keeping the crew on orbit. And again, giving a destination for future generations so that they can step off from there to the rest of the solar system.
Okay, let's take a few more here in the room. There's a microphone in the middle, and then we'll go to the back. Go ahead.
Doug Money, TMC Satellite Spotlight. Frank, just for the record and for my refreshment, can you go through some of the firsts on this flight? Obviously the first flight of the rocket, but this is also Orbital's first liquid-fueled rocket, correct? And I believe that this is also like the first flight of both of the Aerojet AJ-26 engines and maybe even the Russian heritage parts in there. Are there more firsts in there that I'm missing, or does that about cover it?
No, you're correct. Those are some of the first on this. It is Orbital's first liquid rocket that I'm aware of. Dave Thompson, as a kid, may have launched a couple of liquid rockets that I don't know about, but because he started early. But it is the first one we've done on a commercial basis that I'm aware of. Antonio, is there any others?
That's correct. In terms of first, don't forget ATKs.
Oh no, I'm getting to that, but Antonio's always about 2 steps ahead of me. But yes, it is the first flight of the AJ-26. It's a dual engine configuration, and it's the first time we've fired those two engines together in a dual configuration for that long. We'd done a 30-second firing earlier this year, and all the other firings we did were single engine tests at Cygnus. It was the first flight of the ATK Castor 30 engine, which is a new solid, and great job to ATK. And it worked as designed. And they've got an even better version of it coming along as we proceed through the program, up to a 30XL that'll give us quite a bit more thrust and help us carry more cargo. It was the first flight of this particular fairing, larger than any fairing we had flown before, a similar design to previous fairings, but improved, and it all worked as designed. It was the first flight that I know of, other than Little Joe, that was a liquid launch from here at Wallops. And maybe some of the Wallops people can correct me on that, but Little Joe was a test of the abort system for Apollo. But this is the first commercial liquid rocket from Wallops that I'm aware of, and the first liquid off of Pad 0A. I don't know if it's the first brush fire as a result of a rocket launch or not. We put as much water as we could on that pad, but I guess we didn't spray it in the right place. Any other firsts that I'm missing, Dave or Antonio? Okay.
That's good. We'll go to the back.
Is this the largest crowd Wallops has ever had for a rocket launch? That would be my question.
We'll find that out. That's a good data point.
Hi there. Well, I'm Margaret Howell. I'm from RT-TV America. I'm a correspondent. I have two rather less technical questions for you. The first one would be, can you give us an idea of how much this little venture of yours actually cost? And then the second question would be, do you see a cross-country competition being sparked from this possibly? Where other people are trying to get this up just as we've done here in Virginia.
Well, there's already plenty of competition going on to launch commercial cargo and commercial crew, and as well as tourists and others. And I think you'll continue to see that for quite a while in a wide variety of capabilities and concepts. Our intent, of course, is to keep going with this and along with others who are providing cargo services to keep the space station supplied. As far as the cost, The cost of the whole pad complex, which was funded by multiple sources, including the state of Virginia and Orbital, was approximately $140 million. And that's a pretty good investment in the Eastern Shore here, and I think it has paid off. And we believe that the local community has been a major part of us being here, a major part of our success, and we certainly appreciate their support and sometimes their tolerance of large payloads being hauled down the road at midnight out to the island. But just locally, that's been the investment here. Orbital itself, in conjunction with our partners in NASA, has invested probably about $300 million in the spacecraft, and a slightly larger amount in the rocket itself. So it's a pretty big investment, but it's going to, I think, demonstrate a commercial capability that will pay off in the long run. We obviously are hoping for more customers to use this system. We're going to have quite a good business going initially with the cargo delivery, but we're going to have more capability in that. We look forward to using this system for many, many years to come.
Okay. We'll go here to the back left. My left.
Cody Leibowitz, WMDT 47. Alan Frank, can you go into it a little bit about what this actually means for the community, for the Eastern Shore, for Accomack County?
Well, I can tell you from our perspective, we've had a number of people move here and who are living in the community now, many on a permanent basis, some on a temporary basis from wherever they were working before, but who they were told, if you can go to Wallops for about 6 months, we'll get this thing off the pad. Well, that was about 2 years ago, and for a lot of them. So they have really invested in this and made a lot of personal sacrifices to help get this rocket off the ground, and we certainly appreciate what they have done. Mike Laley and a number of other people are great examples of that. But I do think in circulating around the community, meeting some of the leaders here, they seem really happy about the fact that we're here and we're bringing more business to the Eastern Shore. It's certainly changing the complexion of the launch operations here, and the fact that we are bringing in more high-tech and larger rockets, I think, will help encourage more industry to come into this area, and we're hoping it will encourage the students of this area to pay a lot more attention to science, technology, engineering, and math, and to see that as a way to better themselves and to further their educations and get into something really exciting. That's always been something Wallops has done a very good job at in a variety of areas, but this gets a lot more attention than some of the other things that are going on, and we hope that it'll spread throughout the schools and throughout the communities. And we hope also people see us as a positive addition to the community. We're sorry about having to move all the overhead lines and the traffic lights and stuff so we can move our payload, but you got new traffic lights out of it. So
I think you're going to see sustained activity here. Orbital has a number of flights already on the books, eight flights to the space station over the coming years. There's going to be a lot of activity with the space station cargo coming here and the integration. So this was not a one-shot deal. They're going to be here a while.
Yeah, every 3 to 6 months.
Okay, let's take one here, and then we'll go back to the front.
Hi, I'm Denise Ryan, and I'm here today through the NASA social program. Going back to the brush fire, I was surprised to see that the liquid or the water in the tank by the launch pad wasn't used today. Could you go into that decision, or would it have even worked?
Oh, it was used. Oh. Yeah. We don't spray into the brush. We spray on the pad to protect the pad and protect the rocket. For a variety of reasons, partly to dampen out the shock waves that come off, reflected off the pad, but also to cool the pad surface and to cool the trench that the flame goes through before it goes out over the ocean. And that's the main purpose of the 200,000 gallons of water that came out of the tank. And it did work. We're sorry again that we didn't spray any of that direction, but we were out of water by then. And they have a great fire department here, so I know they took care of it.
And a couple of follow-ups in the front. Were there anybody didn't have a chance to ask a question yet? Okay. So let's go here, 1, 2, and then we'll bring it to a close if we can get a microphone down here.
Gene McCullough with Talking Space. Alan, I guess this question's for you. I know around the Kennedy Space Center, they go ahead and they take a very serious look at the wildlife in the area and so on. Did NASA have a similar program for any of the wildlife around here? Just curious.
Yeah,
absolutely. Going into any operation like this, there is always a environmental impact study that's done, and it's a very thorough assessment of the impacts from the environment, and there were no adverse findings from those studies, but it certainly was looked at.
That was one of the early milestones we had to achieve, was making sure that we and NASA worked together, as well as Mars on an EIS, and make sure that everything was as it should be in that regard, and that all came out good.
Okay, we'll take our last question from Stephen Clark. Go ahead.
Thanks. Stephen Clark, Spaceflight Now again for Alan. Just a question, based on your experience with SpaceX and their COTS test flights, do you feel like that sort of smoothed the road with Orbital going into this launch and then the next launch? There was a pretty lengthy delay between SpaceX's test launches, and sounds like you're going to be ready to go in a couple of months. I'm just curious does that reflect on Orbital, or does that reflect on the process being improved? Thanks.
Well, I think it's hard to draw a comparison, because what happened with SpaceX was different here. In SpaceX's case, they made a conscious decision to upgrade the engines and do some upgrades to the vehicle from the initial flight of their launch vehicle to actually flying the COTS demonstration, and then accelerating what was to be the third mission to the station down into the second flight. Took some extra time. So there was a different evolution of their vehicles from the maiden flight all the way to the space station, which could account for the length of time in that period. And in Orbital's case, they don't have that evolution. It was originally planned just to have one demo flight immediately to the space station, and we were able to insert this inaugural flight today. There should be very minor changes between what was flown today and the vehicle that will fly the next demo flight. So it's just a different history, a different evolution.
Okay, gentlemen, anything you want to add before we draw to a close?
Sure. Again, I want to point out the fact that this is all about people. People working hard, people being innovative, people being willing to work together, and people communicating about very difficult problems. That's how we get to space. You work hard, and you bring the right talent together, and then the hardware comes out of that, and the operations. And this was a good example of that. There'll be more to come, but that's been the history of our space program, is smart people committed to some very difficult goals and being willing to take chances and risk failure, achieving great things. And we feel like today we did take some risk getting here, because as a company it was a huge risk to invest in this. But the right people pulling together and with great teammates were able to achieve this. And we're real happy. We're real proud. Thank you all for your support.
And I would just add that this is this is an investment for NASA. This is a new way of doing business, and with any investment, there's a certain amount of risk, but it sure is nice to see a return on investment and things go your way. So I think this was a great day for everybody.
Okay, well, that's going to do it here from NASA's Wallops Flight Facility in Wallops Island, Virginia. As a reminder, you can find out more information about today's test launch at www.nasa.gov/orbital. You can find out more information about how to connect with NASA on social media. Continue the conversation there at www.nasa.gov/connect. We thank our speakers once again. Thank you for joining us. From NASA's Wallops Flight Facility, I'm Trent Parado. Have a good evening.